Welcome everyone to today's podcast on an innovative frontier in language models, large language diffusion models, and especially the LLaDA model that challenges the traditional autoregressive paradigm.
Thanks for having us. I've been itching to dive into how LLaDA uses a masked diffusion approach rather than token-by-token prediction. It's like painting a picture by gradually revealing the canvas instead of sketching each line one by one.
Absolutely. And from a technical perspective, the model's reverse process that iteratively unmasks tokens via a mask predictor is fascinating. It's akin to solving a jigsaw puzzle where you recover a full image from scattered pieces with each step.
Building on that, the technical nuance in the forward process, where each token gets masked with a varying probability from 0 to 1, permits the model to learn bidirectional dependencies, which fundamentally changes how the context is captured compared to classical autoregressive models.
And let's not overlook the business side of things. Think about a retail chain using such diffusion models to enhance their natural language customer support. The ability to generate coherent and contextually aware responses all at once can definitely cut down training time and boost customer satisfaction.
I agree. What's compelling is that even after scaling to 8B parameters, LLaDA shows strong scalability in both instruction following and in-context learning, which is critical for enterprise applications where precision and speed are vital.
Let me play devil's advocate here. While the model's efficiency is impressive, isn't it a bit sensitive to optimal remasking parameters during inference? I mean, experimenting with low-confidence remasking and semi-autoregressive strategies can be tricky in a production environment.
That's a great point, Expert 6. Yet the flexibility in remasking strategies, like using a lowest confidence heuristic, offers a clear advantage. It's like tuning an engine on the fly. If you get it right, you're cruising at high speeds. If not, you might stall a bit.
And adding a dash of humor. Expert 6. Are you sure you didn't invent these masking strategies as an excuse to confuse us? But seriously, this technique really improves the reversal reasoning capability, where traditional models often fail.
In fact, a case study highlighted that LLaDA was able to outperform even GPT-4o on reversal poem tasks, effectively addressing what's been known as the reversal curse in token prediction.
Yes, and from a business invasion perspective, companies in sectors like finance or legal services can leverage these reversal reasoning abilities to generate more accurate document summaries and even legal drafts where consistency in language is crucial.
Exactly. Imagine a financial institution using a diffusion model to parse through complex regulatory documents, generating summaries that are both contextually rich and accurate, which could reduce compliance risks by a significant percentage.
And on the technical side, the model training itself is quite rigorous. Pre-training on 2.3 trillion tokens with 0.13 million GPU hours showcases the massive computational investment needed, yet it's promising how comparable the performance is with established autoregressive models.
Right, and what's striking is that LLaDA eschews the causal mask, meaning it sees the entire context during prediction, which naturally gives it an edge in understanding context holistically. This is crucial for complex multi-turn dialogues.
To put it in perspective, it's like being handed the complete roadmap rather than a step-by-step itinerary. This allows the model to plan the route more effectively, both technically and methodologically.
And let's dive a bit deeper into the diffusion aspect, the iterative reverse process, governed by a principled lower bound on the negative log likelihood, ensures the model is statistically consistent and scalable, an insight originally motivated by Fisher consistency in extreme cases.
In business applications, this theoretical foundation translates into robust performance even in edge cases. Imagine a multinational organization that needs consistent AI responses across various languages and cultural contexts. LLaDA's bidirectional approach inherently supports that.
From a metric standpoint, evaluations on benchmarks like MMLU, GSM-8K, and Human Eval demonstrate that LLaDA holds its own against models such as Llama and even Llama 3, especially in math and Chinese language tasks, critical for diverse business markets.
And interestingly, the integration of supervised fine-tuning, SFT, using 4.5 million aligned instruction pairs further cements its utility in real-world applications where instruction following is as important as pure generation quality.
I also want to mention the semi-autoregressive sampling technique, dividing long responses into blocks and generating them left to right while using remasking strategies improves coherence dramatically, particularly in multi-turn dialogue settings.
That's a game changer for enterprise chatbots. For example, a company using AI to manage customer service can deploy such a model to ensure a natural, human-like conversation flow, iteratively refining each block based on context.
And it's not just conversational AI. A content creation platform could use LLaDA to generate detailed articles or marketing content with balanced creativity and factual accuracy, leading to cost reductions in content production.
On that note, think about how exactly a retail company might cut costs by, say, 15%, using an AI-enhanced system to automate data entry and customer queries, recalibrating resource allocation in real time. That's the kind of strategic business impact we're talking about.
Exactly, and let me add, this approach could also be seen in financial algorithms, where risk assessments and market predictions benefit from the AI's ability to process context in bulk, much like the simultaneous token prediction in diffusion models.
One unexpected insight, though. While most focus on the computational overhead of diffusion versus autoregressive models, I believe the real bottleneck might be in the interpretability and alignment of outputs with user expectations, which is something that sustainable business AI should always address. Ooh, plot twist. Now that's an angle we haven't unpacked enough. How do you all see that challenge being overcome in the next steps of AI adoption?
Well, alignment techniques such as reinforcement learning from human feedback, RLHF, might be the next logical step for LLaDA, further bridging the gap between technical capability and user-aligned outcomes.
And not to mention, integrating unsupervised classifier-free guidance has already shown promising results in tuning the model's outputs during inference, striking a balance between creativity and adherence to the prompt.
I see strategic partnerships emerging between AI research labs and business consultancies. Imagine joint ventures where technical experts and business leaders co-create solutions that tailor these diffusion models to sector-specific needs.
Absolutely. And in my experience, real-world validation often comes from pilot projects. Companies in healthcare or legal sectors could start small, refine the model for domain-specific language, and then scale up once the efficacy is proven.
That's the 80-20 rule in action. Focus on the 20% of changes that will deliver 80% of the benefit. A targeted rollout in high-impact departments could serve as a blueprint for broader adoption.
And as always, continuous feedback loops will be essential. Businesses should monitor outcomes closely, iteratively fine-tuning the model, sort of like adjusting a high-performance car mid-run to achieve optimal results. Incredible insights, everyone. It's clear that LLaDA isn't just a technological novelty. It has tangible implications for the business world across industries.
Exactly. It's about merging cutting-edge technical breakthroughs with strategic business objectives, creating models that are not only smart, but also highly applicable in real-world scenarios.
And let's not forget the role of humor and human touch. After all, AI should enhance our lives, not turn them into algorithmic riddles.
Well said. As Einstein once quipped, imagination is more important than knowledge, and these models truly embody that spirit by combining data-driven rigor with creative inference.
I think we're on the brink of a paradigm shift where diffusion models could redefine how we think about generative AI, making systems more robust, flexible, and aligned with human intent.
To wrap up, the key takeaway is that while challenges remain, especially in fine-tuning and interpretability, the blend of technical sophistication and strategic insights from models like LLaDA paves a promising road ahead for both tech and business leaders alike.
Agreed. If we continue to iterate and learn from real-world deployments, we might soon witness a revolution in how enterprises harness AI to drive efficiency and innovation. Wow, what a rich discussion. Thanks to all our experts for shedding light on both the technical marvels and the business implications of large language diffusion models. Stay tuned, everyone, for more deep dives into the future of AI. Welcome back to part 2 of our deep dive into large language diffusion models, where we're breaking down the technical implementation details and exploring further business applications.
Let's get technical. One core component of LLaDA is its mask predictor, which uses a vanilla transformer without causal masking, so every token is observed simultaneously. This design choice underpins the model's bidirectional inference capability.
Right? And diving into the implementation, the model leverages a continuous masking probability T sampled uniformly from 0-1 during pre-training, which contrasts with traditional fixed masking ratios in BERT. The variation ensures that the model is exposed to diverse missing information scenarios during training.
And on that front, the algorithm optimizes a rigorous cross-entropy loss over only the masked tokens, essentially forming an upper bound on the negative log likelihood, ensuring that our diffusion process is statistically sound, a concept rooted in Fisher consistency.
From a business perspective, this rigorous approach means that the generated model responses are not just coherent, but also reliable over various contexts, which is key for critical applications like financial reporting or legal document drafting.
Absolutely. And let's not forget the practical side of things. When deploying such models, companies can use supervised fine-tuning, SFT, with millions of aligned instruction pairs, thereby tailoring the model for domain-specific tasks such as customer support chatbots or automated code review systems.
Expert 6. Adding a twist, the reverse process in LLaDA employs strategic remasking. For instance, with low-confidence remasking, tokens with the lowest prediction certainty are remasked and reevaluated in subsequent steps, which significantly boosts performance in tasks requiring reversal reasoning.
Technical implementation also involves semi-autoregressive sampling, where a long sequence is partitioned into blocks processed from left to right. This blockwise approach marries the benefits of autoregressive and diffusion-based methods, ensuring both high coherence and efficient computation.
And let's touch on the engineering detail. The training regime uses a warm-up stable decay learning rate scheduler, linearly ramping up initially, then plateauing, and finally decaying, which is essential for handling the massive 2.3 trillion tokens in pre-training while maintaining stability.
Transitioning to business applications, consider a global media company that can implement such a model to dynamically generate multi-turn dialogues for interactive news stories. These models enable real-time editing and content creation that align closely with audience engagement metrics.
Moreover, in the retail sector, diffusion models like LLaDA can drive conversational recommendation engines. Imagine an online store where customer queries are answered not just accurately, but with context-aware narratives that enhance the shopping experience, ultimately boosting conversion rates.
I've seen firsthand how a startup integrated a similar architecture to reduce customer support response times by 30%. The key was leveraging the model's ability to understand complete context up front, cutting out unnecessary follow-up questions.
And this isn't just theoretical. The iterative inference with unsupervised classifier-free guidance allows fine-tuning in production environments, so businesses can adjust parameters in real time to match shifting user demands without retraining the entire model.
To sum up the technical deep dive, the combination of a robust diffusion-based training paradigm, innovative remasking strategies, and a carefully designed reverse process ensures that LLaDA excels in both predictive accuracy and operational efficiency.
On the business front, these capabilities translate into enhanced customer engagement, cost savings in operational processes, and the flexibility to adapt models across diverse domains, from healthcare diagnostics to financial analytics.
And an unexpected insight here. While many focus on scalability challenges, the real competitive advantage lies in how these diffusion models align with real-world workflows, reducing manual oversight and driving automation in sectors that were previously hesitant to adopt AI.
Incredible. The blend of technical innovation and clear business value makes large language diffusion models a truly disruptive force. Thanks for this in-depth exploration, everyone.
It's exciting to see how the convergence of advanced algorithms and strategic deployment can shape the future landscape of AI in business.
Indeed, the next few years will likely see these models integrated into industries in ways we've only started to imagine, like having an AI that not only understands language, but also the nuances of human engagement.
And with continuous improvements in training and inference pipelines, we're set to overcome current challenges, making these systems more interpretable and reliable for enterprise-level applications. That wraps up Part 2. Thank you all for joining this technical and business deep dive. Stay tuned as we continue to explore cutting-edge AI innovations in our next episode. Welcome back to Part 3 of our podcast, where we wrap up our deep dive into large language diffusion models, summarizing the key highlights and insights from our discussion so far.
To kick things off, let's recap the crux of what we explored. LLaDA's use of a diffusion process for language modeling, which diverges significantly from the traditional autoregressive approaches by enabling bidirectional token prediction and effective reversal reasoning.
Right. And from a technical standpoint, the innovations are truly impressive. Using a continuous masking probability, the clever application of low-confidence remasking, and the semi-autoregressive sampling that partitions long sequences into manageable blocks. It's like rebuilding an engine while driving the car, keeping the system efficient and reliable even under extreme conditions.
I'd add that the rigorous cross-entropy loss, which serves as an upper bound on the negative log likelihood, ensures statistical soundness and ties back to Fisher consistency. That technical foundation is what ultimately boosts the model's predictive reliability.
On the business side, these technical improvements translate directly into real-world benefits. Imagine a financial firm using these models to generate detailed reports in real time. Accuracy and reliability paired with cost efficiency can really put a company ahead of its competitors.
Absolutely. And we saw applications like interactive customer support systems reducing response time by 30% as a tangible business case. This marks a strategic shift. Businesses can now achieve high levels of engagement and operational automation without excessive retraining costs.
And an interesting contrarian point. I believe that while scalability challenges often dominate the conversation, the real breakthrough is in simplifying integration with existing workflows. When a model can adapt to real-time parameter tuning, the business value shoots up dramatically, even in industries traditionally resistant to AI adoption.
Reflecting on the training methodology, the warm-up stable decay scheduler and the massive pre-training on 2.3 trillion tokens underscore the model's durability. It's designed to handle both general queries and domain-specific nuances with minimal manual oversight.
And don't forget the reverse process strategy. Through iterative inference and guided remasking, LLaDA not only excels in forward reasoning tasks, but also overcomes limitations like the reversal curse, a notable advancement in handling complex and unorthodox query formats.
Yes, and it's impressive how these techniques, traditionally rooted in deep theoretical constructs, are bridging gaps to offer performance on par with or even exceeding established autoregressive models. This is a clear indicator that the future of language modeling might well pivot around diffusion-based approaches.
For business leaders, this shift means more robust systems for tasks ranging from conversational AI in retail to dynamic content generation in media. Companies can leverage these models to cut costs, drive engagement, and foster innovation in ways that were previously unthinkable.
And if we look at the bigger picture, the integration of advanced diffusion models into enterprise workflows is likely to spur a whole new ecosystem of AI applications. ones that prioritize context-aware decision-making and real-time adjustments to meet evolving market demands.
In summary, our discussion illuminates how the technical depth, from precise masking strategies to semi-autoregressive sampling, merges seamlessly with business imperatives of efficiency and adaptability. It's a blend of theory and practice that sets a new standard in the field. What a comprehensive journey it's been, from dissecting intricate algorithms to linking them with tangible business applications. As Einstein famously said, imagination is more important than knowledge, and today's conversation shows that, when applied right, imagination can revolutionize entire industries.
Precisely. These models are not just academic exercises, they're paving the way for innovative solutions that drive real-world change.
And humorously enough, while some might have expected these ideas to be as convoluted as assembling IKEA furniture without instructions, our conversation shows that, with the right guidance, the pieces click together quite elegantly.
It's been enlightening to see how each technical nuance contributes to an overall strategic advantage, and how such models can seamlessly scale from concept to impactful business applications.
For every tech leader and business executive listening, the key takeaway is clear. Invest in diffusion-based innovations today, and you're setting the stage for tomorrow's breakthroughs.
I echo that thought. By embracing these strategies, organizations can not only optimize operations, but also create a competitive edge that transforms customer interactions and internal processes alike.
And as a final thought, it's exciting to anticipate where these advancements will lead, perhaps even beyond language tasks, into multimodal domains and integrative agent systems that redefine what AI can do for our world. That brings us to the end of our deep dive series. Thank you all for joining us as we unpack the technical and business dimensions of large language diffusion models. Until next time, stay curious and keep innovating.